Welcome friends to Power Plant Guru YouTube channel. Friends, I am a mechanical engineer with around 20 years of experience in the field of power plant, and I used to create small fundamental knowledge series videos for power plant engineers. We also run doubt clearing sessions on weekends. So if you want to reach us, you can reach us through comment section and join our weekend classes. Let us continue to watch our today's video. Hello friends. So let us understand boiler swelling and shrinking concept in detail. So this is a important thing which anyone who is operating boiler might have witnessed this and may be aware of the concept, but let us understand it in detail. So here is a normal case where you have your boiler where is a steam drum, mixture of water plus saturated steam, and then there is a natural circulation or forced circulation of water is happening like this, and then you have your steam going to the load. So if we talk about steady state, what does it mean? Steady state means that your normal operation is happening, then this feed water flow will be equal to your steam flow, and there your level is constant, almost constant, not exactly constant, but yeah, level is same. So why same? Because whatever steam you are taking, the same quantity of water you are feeding into the boiler, and your three element level control is taking care of that. But let us consider a case where this steady state process changes, and how it changes there. So I'm taking a case where you have your multiple boiler connected in one system. Maybe three boiler will take, for example, maybe boiler 1, 2, 3 main steam lines are forming a header, and then from that header there are two turbines are operated like this. This is T1, this is T2, just for a understanding. So this is how the steam flow is there. Now let us take a case when your every system is stable. Now this B2, what will happen if this one boiler trip? So this trip means there will not be any steam flow from this. So this supply cutoff will definitely reduce the pressure here in this entire region, because turbine is still consuming, and here is the one steam source which is cut off. So these boiler 1 and boiler 3 will try to push steam into this void or low pressure condition. Then what will happen? Just imagine if it is this boiler 1, then this boiler 1 will witness a lower steam pressure, because the entire system is short of the steam demand. And then this lower steam pressure, there is a if we try to imagine, this is the pressure on this water. So if this pressure is reduced, then what will happen? This whatever water was there, this will try to go upwards. Whatever pressure was there, that was trying to bring this water to that level, but now imagine this pressure is little bit reduced, so this level will try to go up. So this is the one phase of your swelling, which you can notice that this is how the swelling will happen. This is one, that lower pressure will try to push that water which is inside the drum. Second thing is, if you are aware of flash steam concept, that water will convert into steam at when you decrease the pressure. So there will be some flashing also of steam. So that flash also causes so transient high levels. So these two things are making your drum level to go on a higher side. So this higher side is called swelling. Hope you understood. 2 points. One is water was under a pressure, and that pressure, let's say X, was maintaining this level, and the pressure was is less than X in a very short span of time, then this level try to jump off. That's one factor. Another factor will be there will some flash steam will be generated, which will again push that turbulence in the system, and there will be level a little bit higher. So these are two things which will make your level high. Now, if there is a high level, which is what we are speaking like this is a high level. And what we were speaking, if one bowler is tripping, the other two bowler definitely will try to support. So that is this steam flow high. These both bowler will try to push that steam, and then there will be higher load on these bowlers. You have to maintain, operator whosoever will be there, he will definitely try to maintain, but suddenly this thing will happen. Now what will happen if your level is high, then what should happen? Your feed water flow should be reduced. Okay, so that is why your 3 element level control will try to reduce the water. But as this condition is not a permanent condition, a stabilized condition, this is a transient condition. So once this is stabilized, you reduce that your flow, you take the boiler in manual, control the flow, control the fuel, you do all that thing. So by the time your boiler feed water, which has seen the drum level is going high, it will try to reduce the flow, and that is this impact which you are seeing. So after this high, drum level controller is trying to reduce the flow, and there you see that after normal level there is a little bit dip. So that is why, after that drum level swell, there is a little level down is also there. Hope you have understood the swelling concept. If you got it, let us know in comment section, and if you have any doubt, you can definitely ask questions in comment section. Let us try to understand shrinking. So shrinking is just opposite of what we have seen in the swelling. So as I took an example of 3 boilers in a row, B1, B2, B3, and similar example we can also take in this case to understand that this flow situation, that if you suddenly reduce this flow, then what will happen? So how this flow is reduced? So let us take a case where these 3 boilers are there, and then you have T1 and T2, which is one turbine and which is another turbine. So in case one of the turbine trips, then what will happen? There is no consumer. Sorry, there is one consumer is out. There's still one consumer is there. So there is a cut in the demand. Then what will happen? The pressure at these pipelines will definitely increase because boiler is still feeding the steam, but there is no such demand as earlier. So this will go to a higher pressure. So this will go like you can see here. and what will happen, there will be, the pressure on this section, on this water, will be high. So it will try to, push the water level to the downside. And as you can imagine, there will be lot of, water bubbles in this area also, and that will also be, like shock, or you can say crushed, so that this higher pressure is pushing those bubble to burst and compress. So that will also a temporary phenomena which will cause your levels to go low. This is also, the pressure is also pushing the water to go down, as well as these bubbles which are here everywhere, that will also go smaller, and then this will also push that water into this area, and then your drum water level will go down. That's what you can see. As you are reducing the pressure, the flow, the pressure will go high, and the pressure will go high, which will try to reduce your level. This is a temporary situation. Actual level, I mean to say that this you cannot say that this is going to be actual level, because after only some time this level will again shoot off, because what we have seen is, as level is reducing, then VFW, feed water flow, has to increase, but the actual flow is not that reduced, because this is not a stable condition, operating condition. After this turbine trip, definitely the fuel will be reduced, and then the pressure will be normalized. As you do that all process, by that time already the feed water flow is higher, and once you settle down with that higher steam water flow, your drum level will go little off that normal limit, and it will be little higher after that cycle. So this is how the shrinking effect works. And this also can happen when you are hooking that, let's say you have a battery of different boiler 1, 2, 3, 4, and so on. And then these boilers are already operating in your one battery, and giving steam to turbine, or maybe chemical plant, or maybe refinery plant. And then you are starting up this one boiler, and then hooking up that boiler. So hooking up that boiler means you have to be a little bit higher pressure, operating pressure, then you can push that steam. But as you do that, there will be a little pushback from these boilers also. So that's why this kind of shrinking and swelling you can see in many turbulent conditions, where you are starting the boiler, or you are hooking up that boiler into the battery, or your turbine, another turbine trip, or the boiler trip. But ultimately the concept would be your how the flow is changing, whether it is very steep high demand, or very steep lower demand, or delta P. So that is how your shrinking and swellings are connected. Hope you have understood, and just let us know in the comment section if you have got it, or if you have any other question, you may please ask. Thank you for watching us. Thank you.